Hey, what's up YouTube? So in this brief video I'm going to show you how you can power up your LEDs, your incandescent bulbs, as well as DC motors and fans using a simple rectification circuit. So the circuit is really quite simple here. AC comes into the primary winding of this transformer and then outputs to this secondary winding here, which is connected to the rectification board here. And I've modified the rectification board with two wires. For driving the LEDs and everything else, I'm using this custom driver here, which uses the LM338T semiconductor, as well as a 33k ohm resistor. So here's the rectification board here. It is consistent of a standard electrolytic capacitor rated for 16 volts at 3,300 microfarad, and then that gets sucked down into the full bridge rectifier here, and that is made up of 4 in parallel diodes, as well as 4 in parallel ceramic capacitors for filtering. So here you can see under the rectified board here, I've modified 2 points here. One is a negative 7 volt potential, and the other is a 13 to 18 volt positive potential. So using this wiring configuration here, we can see we have a readout for 7 volts, almost on the dot there. And that's coming from the positive out of the semiconductor here, as well as the negative 7 volt potential coming from the rectification board there. And here's the other configuration, which gives us a total readout of 17.3 volts. And again, that's using the positive out here from the semiconductor, as well as the negative out of the 13 volt potential here. So here I've configured and wired up a red LED, which gives us an output reading of exactly 1 volt. So this is working very well. And now for a green LED. We have an output reading here of 2 volts, pretty much right on the mark. Working quite well here. Now the green LED may look brighter, but that's only because our eyes and phone sensors are more sensitive to green light. Now for some incandescence. Instead of using the 7 volt potential, I'm using the 13 volt potential. And we actually have a readout output voltage of 13 volts there. So this is working very well. Now for some DC motors. Here I have this DC motor connected to the 13 volt output. And here we have a stable voltage readout of 12.4 volts. So yeah, this is working quite well here. Here I have a relatively bigger DC motor here connected to the 13 volt output, and here we have a readout of 12.7 volts, which is relatively stable. Here you can see changes in voltage when I apply pressure to the rotor here. You can see noticeable increases in voltage. And that's simply the motor and circuit compensating for that additional pressure or load. And now for this blower motor here. We see a relatively stable voltage there with a potential of 14 volts. Everything looks good. And a white LED, of course, with an output reading voltage of 2.5 volts, pretty much right on the mark. And here I have a high power rated LED giving an output reading voltage of 14.1 volts there. Very bright. This LED board pretty much lights up the whole room. This light is so bright it causes a shuttering effect on the camera's lens there. This board is in fact getting hot, so I wouldn't want to run this for a very long time here. Discharging the capacitor. So after discharging that capacitor, I want to make sure that the power supply is still in good working condition. So to do this, I'm going to start off with measuring the low voltage output here. And this should give us a potential of 7 volts there, which is pretty much on the notch. And once we unplug here, we can see a nice discharge back down to 0 volts there. And earlier the capacitor was discharged with the power supply off. And of course a blue LED. Red LED. The green LED. And here we're starting off with 7 volts, and we see an increase there to nearly 10 volts with this incandescent bulb. It draws a fair bit more power than some of those smaller LEDs there. An even bigger incandescent bulb here.